In this video, we're going to learn about something called the change of base formula. The change of base formula allows you to rewrite logarithms in one base as logarithms in other bases. This is particularly useful if you want to compute a logarithm using your calculator. Most calculators only have a log button and a ln button. The log button means we're doing log with base 10, and the ln button means we're doing log with base e. So you might ask yourself, how do we compute something like log with base 2 of 25? So to answer this question, you want to think 2 to what power gives me 25? Well, we know that 2 to the fourth power gives us 16, which is a little bit smaller than 25, and 2 to the fifth power gives me 32, which is larger than 25. So our answer has to be somewhere between 4 and 5. But let's say we want an exact answer. Well, how would we type this into our calculator? We would need to change the base of this logarithm, so it's either base 10 or base e. That way we can use the log button on our calculator or our ln button on our calculator. Let's see how we would go about doing this. To begin, we're going to name our logarithm here x. So let x equal to log with base 2 of 25. What we're going to do is take our equation here and perform operations on both sides so that we can eventually rewrite that x as a logarithm with a different base. The first thing we're going to do is exponentiate both sides of this equation with base 2. That means we're going to do 2 to the power of the left-hand side and 2 to the power of the right-hand side. This leaves us with 2 to the x on the left-hand side, and on the right-hand side, we have 2 to the power of log with base 2 of 25. Now remember that logarithms with base 2 and exponentiation with base 2 are inverse operations of each other, meaning if they're performed back to back, those two operations will cancel each other out. And that's what's happening here. The log with base 2 will cancel out with the exponentiation, leaving us with just 25 on the right-hand side. So we have 2 to the power of x equals 25. Next, we'll take the logarithm with any base of both sides. Now, in general, when we take this logarithm, we can use any base we'd like. However, if our goal is to compute x using a calculator, we'll want to take the logarithm with base 10 or base e. Let's say we use base e, which means I'm going to take the ln of both sides, the natural log of both sides. This leaves us with ln of 2 to the power of x on the left-hand side and ln of 25 on the right-hand side. Now, this is where we're going to use one of our log properties. Remember that if we have an exponent inside of a logarithm, the exponent can be taken out as a multiple. So we can rewrite that left-hand side as x times ln of 2 equals ln of 25. And now, if we want to get x by itself, all we have to do is divide both sides by ln of 2. So divide the left-hand side by ln of 2, divide the right-hand side by ln of 2. On the left, these two ln of 2's will cancel out, leaving us with just x, and on the right, we have ln of 25 divided by ln of 2. So we see that our original logarithm, log with base 2 of 25, is equivalent to ln of 25 divided by ln of 2. Before, our logarithm is base 2. Now we have natural logs, which is logarithms with base e. And ln of 25 and ln of 2 are things that we can type into our calculator. Typing in ln of 25 into our calculator, we end up with 3.21888 if we round. And if we type in ln of 2 into our calculators, we get 0.69315. Now, if we divide these two quantities, we'll end up with 4.644 approximately. So this is how we compute log with base 2 of 25 in our calculators. Since calculators typically don't have a log with base 2 button, we convert this expression into an expression involving natural logs, which we can type into our calculators. Now, what we've done here is essentially the math behind the change of base formula, which says that if we have log with base a of some quantity c, this can be rewritten as log with base b of c divided by log with base b of a. Now this base b can be any base we'd like. Now if we want to compute the original logarithm in our calculators, typically we'll use base e or base 10 because our calculators have a natural log button and a log button. So we'll typically rewrite our original logarithm as ln of c divided by ln of a, or log of c divided by log of a. So let's use our change of base formula to help us compute some logarithms. In example A, we want to compute log with base 5 of 10. So according to our change of base formula, we can rewrite this as ln of 10 divided by ln of 5. Or alternatively, you could have also done log of 10 divided by log of 5. So let's type this into our calculators. ln of 10 gives us 2.30259 if we round. And our denominator, typing in ln of 5, we get 1.60944 if we round. Now, if we divide these two quantities, we end up with 1.431 if we round. So log with base 5 of 10 is approximately 1.431. Let's now look at example B. Here we have log with base 3 of 70. Again, using the change of base formula, we can rewrite this as ln of 70 divided by ln of 3, or alternatively, we can do log of 70 divided by log of 3. Either way works. I'm just choosing to use log with base 10 this time. Typing in log of 70 into our calculators, we end up with 1.84510 if we round. And if we type in log of 3, we get 0.47712. Now, if we divide these two quantities, we end up with 3.867. So log with base 3 of 70 is approximately 3.867. So in this video, we learned about the change of base formula, which allowed us to rewrite logarithms in one base as logarithms in a different base. This change of base formula allows us to compute logarithms in our calculators. If we have log with base a of c, we can compute it in our calculator as ln of c divided by ln of a, or log of c divided by log of a.